All right, guys, we're going to go on and get started today. Yep, none of this. Now, before we get started, are there any questions over the homework assignment? As I know a good number of y'all have already turned it in. Now,
is there a video posted from yesterday?
Yes.
So I already got the worksheet.
And you got the worksheet? Awesome. So there's not too much to it. If you want to watch the whole video, you can. But if you watch it and get an understanding of it, you can move on to it. Yep. Yes. Now, all right, guys, what we're looking at today is logarithms. Logarithms are the other part of exponentials. Exponential functions, such as b to the x equals y, is an exponential function, where b is a number and our x and y are inputs and outputs. Its inverse is what we call logs. So logs are the inverse of exponential functions. And we can look at this here, so y equals. So we could say 10 to the x, and we get this graph here. And logarithms, log of x, is this one here. Now, we'll get more into inverses later and what an inverse is, but two functions are considered inverses graphically if they are a reflection across the line y equals x. So we'll put a third equation. I'm going to pick. So if we see this here, this line y equals x, the pink graph, the red and blue lines, those graphs are mirror images of each other across this line. They're inverses of each other. They undo each other. And for the most part, and we'll see here, our normal exponential functions are fine, especially with solving. Because if we said 2 to the x equals 8, well, 2 to what power gives us 8? That would be third. 2 to the third is 8. So here, there's different ways to go about it, but we can say that x is 3, yes? Well, the reason that these are nice is if I said 2 to the x is equal to 5. Well, 2 squared is 4. 2 to the third is 8. Is there a number that works for this here? Well, there is. It just takes us a little while to get there, and logarithms are going to be helpful for actually finding this. And a logarithm in our exponential follows this here. Log base b of y equals x if and only if b to the x is equal to y. Make sure I get it lined up. Y equals x if and only if b to the x is equal to y. So we can change from one form to another and go from back and forth with these here. So the first thing we do before we solve or do anything else is we're looking at these logs. So they give us this here. And we want to rewrite it in exponential form. So log base b of y equals x if and only if b to the x is equal to y. Now, we're given it in logarithmic form. So log base 2 of 16 equals 4. Now, we don't have to do this every time, but on these first few, I think it'll be helpful to write this out. Our b, what is taking the place of b in this first one? It is 2, because it's our small number, log base b of y. So our base, that b value is 2. Our y value is 16, because it's what's inside the logarithm. And our x value is 4. b is 2, y is 16, x is 4, yes? So according to the formula, b log base b of y equals x, if and only if b to the x equals y. So we're going to rewrite it as b, we're going to rewrite our b of x equals y. Now for us here, our base, our b value is 2 to the 4th power is 16, yes? So we replace b and x, so 2 to the 4th equals 16. Can I calculate 2 to the 4th power? Yeah. And that's one thing that's nice about this is I can grab a calculator, say 2 to the 4th is, and that's what our equation is set up as, yes? So we have it set up correctly. That is the exponential. Yes. So it just says to rewrite it. We don't have to do anything to it. We can do the 2 to the 4th to make sure we have it set up in the right form, because it's very easy to switch some of these numbers, especially here the 2 and 4, because if we flip those, we would get 16 still, because 4 squared and 2 to the 4th are both 16. But any of this here?
I'm so lost.
Okay. So really all we're doing this here is they gave us this equation in this form. Log base b of y equals x. They want us to write it in this form. So our b value for this here is our base of 2. So that's the b value. Our y is what's inside. X is outside. So we got b, y, and x. And we're rewriting it as b to the x equals y. So our b value was 2. Our x value is 4. Y value is 16. Questions on this here? Are you ready for another one? So again, and especially doing these the first few times, it's good to have kind of the reference to it, b, x, and y. We'll go on and write those values out from the given form, because we're looking at it in logarithmic. Log base b of 4 of 1 equals 0. So for us, and comparing it back to the general form, log base b of y equals x, well, our b value in this case is 4. Our x value is
Our x value is
0, and the y value is 1. Because I do have x and y kind of flipped if we were going left or right, and how I listed them. Because y is inside with the log, x is on the outside. Now, so b to the x equals y, yes. Because our b value is 4. Our x value is 4. Yes. Yeah, we have to put the 0 in that exponent, because if we don't put a number there, it's understood to be 1. So if it's 1, we don't necessarily have to write that exponent, but exponent of 0. Because anything to the 0 power is 1. The only exception is 0. And again, the nice thing with this is we could say 4 to the 0 to check it to make sure. And it is nice, we can say that it is indeed 1. Questions on these first two here? Log base 12 of 12 equals 1. So I'm going to do this again, b, x, and y. We don't have to. Our b is 12, x is, y is 12. So ex equals y, so 12 to the first is equal to 12. Yeah. And that's it. Questions on this here? So if we look at the next one, log base 1/4 of 4 equals -1. Well, our b, what's going to go in place of the b is 1/4, yes. Yep. So 1/4, we don't, to the negative 1 is equal to 4, yes? And luckily for us here, we don't have to leave it. We're fine leaving it here because properties of negative exponents, we're just rewriting it. Does that make sense? It's almost like if we're trying to solve it, this is what we get. And this works out because, again, we said to get a negative exponent positive, we have to move it from top to bottom, or bottom to top, which really is just going to take that 1/4 and flip it, which makes it 4. Yeah. Yeah. Questions on this here? Like this here so far? Rewrite each equation in exponential form. Now, I believe y'all's next 4 are not written like this here. I gave y'all a little more space to actually work these instead of having it like this here. But let's start at the top and go down. Log base 6 of 216 equals 3. So our base would be to the third 216. 6 to the third power equals 216. And we would agree with that, yes? Log base 7 of 1 equals 0. So 7 to the 0 is equal to 1.
This one's easy.
21 to the first power equals 21. And the last one would be 1/5 to the negative 1 is equal to 5. I would, especially when we have fractions, it's sometimes understood, but it just works better that way. That way we know it's not just being applied to the numerator, but the whole thing. Alpha y equals enter. What? We need to write it this way. Because even though it is a negative, and we said the other day we've got to keep those negative exponents positive, here we're just rewriting. We're not trying to simplify. We're not trying to do anything to it. So we want to write it this way so we see the correct setup. Does that make sense? And it's almost, at this point, we're not really trying to do anything with it. We're just trying to get used to being able to go from logarithmic to exponential. Because if we're trying to solve this, 1/5 to the x is equal to 5. We need a way to solve for x and be able to go backwards. And that's actually the next part, is we're going backwards. Well, quote unquote backwards. Because up to this point, they gave us the logarithm. They wanted an exponential. Now we're going from exponential to logarithm. And I'm going to write it again because b to the x equals y if and only if log base b of y is equal to x. Now I know I didn't put parentheses around the y when we wrote it the first few times, but we can have it, don't have it, either way. Yep, log base b of y equals x. And for this here, I'm going to do the b x and y again so that we can see this here. Our base b is going to be what? 5. Our x is, and the y is 25. So we have log base b, so our base in this case would be 5 of 25 because our y is equal to, bless you, log base 5 of 25 equals 2. There's ways to calculate this in the calculator, but unfortunately our log button that we have on it won't just give us it because it has a specific base to it. So the button, when I typed these graphs earlier, that log has a base of 10. It's called one of our common logs, is base 10. And since this base is 5, we can't just hit the log button and do that there. There's certain things we have to do. Yes, there are ways to change the base. And there's ways to rewrite it using what we actually call the change of base theorem, to where we can set it to 10. And we will learn that theorem, or that formula that goes with it. Questions on how we got log base 5 of 25 equals 2. Let's look at the next one. So I'm going to do bx and y one more time. Our b in this case is what? 10. B is 10. X. Negative 1. Y. 10. 0.1 equals negative 1. Now, as we said on the calculator, the base for that log button is base 10, yes? So this one, either calculator, we can hit the log, 0.1 is negative 1.
So the 10 I really doesn't matter?
10 we don't have to write. It's almost the same as writing an exponent of 1, so having 10 to the first power. But here, we're going to go on and write it for now. Does that make sense?
So would that be considered the same like if it was 5?
It would not. This would be the same as log of 0.1 equals negative 1, because it's understood to be 10. This is the same as when we write a square root. Yes.
So that's the part that's
Yeah. Because you can write it out. There's no reason to not write 10. But if we do see it as this here, it's still 10. Because especially once we start solving and actually start using these more, because here we're just seeing how they switch from one to the other. If you don't see a base 10, it's understood to be 10. Almost like with square roots. The index is 2. It's just understood to be 2. Or if we just talk about the exponent for this x here, it's understood to be 1. The number in front of x is understood to be 1. So some of those are just understood. But here, this base 10 is understood. Does that make sense? Questions? Let's look at the next one. 8 to the 2/3 equals 4. Log base 8 of 4 equals 2/3. And when we write the 8 for our base, especially this here, make sure it is down lower than a log so it's not level with it. So we understand that it is the base for this here. And what I mean by that is I don't want you writing like this here. We need to know and signify that that 8 is the base, that it's kind of dropped down. Because what this really looks like is log of 8 times 4. You don't need the parentheses. I put them just so it's kind of easier to see, because I believe if you do look at the textbook, they're just going to have it written like this. The only time the textbook will put parentheses is if what's inside the logarithm, so log base 8 of x plus 2, if it's signifying that those two terms are inside the parentheses. One thing that I really don't like that they will do, I'm going to rewrite it, is this here. That plus 2 is not inside the log. Because what they understand is that it's actually log base 8 of x plus 2. It's adding 2 to it. So they will, instead of writing it here so it's understood that that 2 is outside, they will write it like this here, hoping you know that this is not, the x plus 2 are not together, which I don't like as much. Are you ready for the next one? So our next one would be log
6.
base 6,
Over 116 or 216
1 over 216.
equals -2.
That's it. We can put parentheses around the 1 over 216. We don't have to have it, but we can if we want. Now, if there's more than one term, like we saw with x plus 2, and they're both inside, we need the parentheses around it. Questions on this here? All right, let's look at the next set. So let's go on and do these. Luckily, these don't take too much time. I think we've got them, yes. So the first one, log base of equals 2. Log base 20 of log base 16, 3/4. And lastly, log base 15 of 1 over 225. How do we feel about these here? We feel good with these. And we know we haven't had a way yet. But log base 9 of 81, there are ways to calculate this and find its value. So I'm going to bring back one we had earlier, because we said 2 to the third was, well, what we'd written is 2 to the x equals 8. We know that x is 3. Well, the other one I put up here was 2 to the x is equal to 5. And at the start of this lesson, we had no way to find this. How would I rewrite this as a logarithm?
It would be log 2.
Log base 2 of 5. We don't have a way to calculate it yet, but I can calculate log base 2 of 5. We can find its value, and it will tell us what that exponent is. That exponent is going to be irrational. It's going to be an irrational number.
How did you put the 2 in there?
So, well, we can go on and show it. I wasn't planning on showing us that today. But if we go to math, over to, or just down, log base. So math, or just math, and then we go down or up to log base. Well, it would be helpful if I'm not in the graph. Math, log base, 2 of 5 is now that is approximating it because that's not the full decimal. It continues out indefinitely. But that is a way that we can get that there. Now, the yellow calculator cannot do log base like the graphing calculator can. We will go over later, planning on doing it later, log base, or the change of base, where we can get the bases to be our 10. Or when we get to it, E is technically another one. And we can solve from there. Now, we're going to do some evaluating. Now, there's two things that are nice to know. One of them, log base b of 1 equals 0. Does not matter what the base is. Whenever we have 1 inside the logarithm, it's always 0. I would write this. I would definitely write this down. Log base b of 1 equals 0. Because when we rewrite it as an exponential, we get b to the 0 equals 1. Well, anything to the 0 power besides 0 is 1. So if we're ever looking at a logarithm and the number inside is 1, we know it's 0. That's just the way that works. The other one that is nice, log base b of b, when the base and the number inside are the exact same, it equals 1. And the reason this works is because if we rewrite this as an exponential, we get b to the first is equal to b. So these two are kind of nice in each other and kind of nice to have. Now we can calculate these out and use the calculator to find it, but what we're going to do is something a little different. So when we look at this first one, doesn't matter what variable I set it as or what we set it equal to, but I'm going to set it equal to x. And I want to rewrite log base 4 of 64 equals x. Well, okay. We're going to do this a little differently. Sorry, I'm replanning. Because we're using these here. Because I think this is how we'll do it this way, and we'll see how we like it. If we hate it, we'll throw it out. We'll do it a little different. Because one of them says log base b of b equals 1. When the base and what's inside are the same, it equals 1. Well, here our base is 4. So if we can rewrite 16 as 4 to a power, that's going to help us. Because 4, we can take a guess to what power is 64. 4 to the third is so this part here helps if I move this 3 over just a little bit. This here, log base 4 to the 4. Log base 4 of 4 is what? 1. So this here is 1. Well, how many of them do we have? So what do you think this is going to be? It's going to be 3. Now, this is coming into some of the other properties because we're saying we're multiplying it by itself 3 times, so we can move the 3. Well, log base 4 of 4 is 1, telling us this is 3. Because I disagree. It's not that I don't like this method, it's just we're having to make assumptions on properties we haven't covered yet. And using the calculator is nice. Yeah, okay. I assumed wrong there. So we get that there. I'm going to do this one again the way I was going to do it. Because this is what we're wanting to find. Log base 4 of 64. We want to see what does this equal. What is the value of this? Yes? Let's look at it as an exponential. Exponential would say what? 4 is our base, yes? How would we write it? 4 to the x is, so we're saying 4 to what power is 64? 3. Because 4 to the third is 64. Thus, log base 4 of 64 is 3. Does that make sense? And we can break it down even further, because what I could say instead is 4 to, instead of just saying this is 3, we could say 4 to the x. Well, we know 64 is what? 4 to the third, yes? And again, this is pulling in more theorems or kind of stuff we are going to cover later. The bases are the same, yes? So the exponents have to be same, which means x has to be 2. Which is fine, that's great. If we look at the next one, log base 5 of 0.2 Well, we can say is equal to x. How would we write this as an exponential? 5
x equals 0.2.
0.2. 5 to the x equals 0.2. Well, this is hard to kind of put 1 and 1 together, yes? I'm going to grab a calculator. So we're trying to get 5 to be 0.2, yes? And this here, because again, normally we like decimals more than fractions. Well, let's see what this is a fraction. Because 1 over 5 is 0.2. So what we have here is 5 to the x is equal to 1 over 5, yes? Questions on this so far? Because again, I think everything up to this point has had some nice steps from one to the next, yes? This, it's not so intuitive or kind of would make a whole lot of sense to change it from a decimal to a fraction. And the next step probably won't make a whole lot of sense either unless we look at it. Because here, we had 4 and 64. Well, we got both of the bases, both the numbers to be 4 to a power, yes? So it would be nice here if we could get 5s, no fractions, just 5, yes? Well, 5 to the x is fine. But it'd be nice if I could move that 5 from the bottom of the fraction to the... So we can move the 5 to the top, but the exponent becomes -1. Because the exponent is 1 already with the 5, we just don't write it. But when we move it to the top and it becomes negative, we have to write it, which tells us x is -1. Questions on this here?
I do have one question.
Yes.
How do you use the decimal fraction?
So point 2, math, and the first one should be FRAC, enter, enter. All right, let's look at the next one. Log base 1/5 of 125 is equal to x. Exponential form would be 1/5 x. It will be. Because here we're going to have to do some changing. 125. It'd be nice to write it as a 5. I didn't pick 5 out of the blue or just randomly pick it, but we know the other one has a 5 because we have 1 over 5 to the x. Well, we can move the 5 to the top, and it'd be -1 to the x, yes? Which, let's go on and simplify that out. Powers of powers do what? They multiply together, yes? So it's just 5 to the -x. So we have that there. Equals our 5. Well, we need to see, so that's why I picked 5, because I know the left side is going to have 5 to a power, 5 to the -x, is equal to 125. Well, if we're not sure, we can just do 5 to the second. Well, that's 25. 5 to the third is 125. So we're saying 5 to the -x is equal to 5 to the third power. Right, we're saying -x is equal to 3. We can multiply or divide by -1, telling us x is equal to -3. So I think, especially with the last two, we kind of notice a trend, yes? If we go from fraction to a whole number or a whole number to a fraction, most likely the value it's going to equal to is what? Negative. It's going to be negative, right? Because that negative causes it to flip. log of 36, log base 36 of 6 equals x. So this would be what? To the x is equal to, well, we can go one of two ways. We can either turn 36 into 6, because we can do that, or we can try to turn 6 into 36. 6 times 6 is 36, yes? So if we multiplied it by 2, if we said 6 squared would be 36, yes? Well, that also means this 36 is what? So 6 squared is 36. So we bring it and get them to be the same. Well, powers of powers. So 6 squared to the x. Powers of powers multiply. So we have 6 to the 2x equals 6, yes? So we'll finish up with this here. So we're really saying that 2x is equal to 1. Divide by 2, so x is
X equals 1 over 2.
1 over 2. And this here we can check 36 to the 1/2 is indeed 6. We are going to stop there. We'll pick this up on Monday. Yes.